Good morning, mathematicians. Thank you for showing up for your learning. Thank you for tuning in now and getting ready to take a look at maximum and minimum of quadratics. This topic may be one of the heavier algebra topics from grade 10 that we need to review, and that's completing the square. We will do several examples today, and my main goal with this lesson is that you know how to locate the vertex of a parabola given to you in standard form. All right, so now let's take a look at and so we can use algebra to locate the vertex of a parabola and identify, is that a maximum value or is that a minimum value? All right, let's carry on. So we have these forms of the quadratic equation. Y is equal to ax squared plus bx plus c is our standard form. What information can we get about the quadratic from that form? C, you said? Yeah, what does C tell us? Dave, it's the y value of the y-intercept. Yeah, so that parabola is going to touch the y-axis at some point. That point is given by C. Just the same as your mx plus b gave you the intercept, the C gives you the intercept. A also tells you the shape of the parabola and whether it opens upwards or downwards. So A is going to be important for our lesson today as well. The factored form can be written this way, R and S. You'll remember that I like to write it R1 and R2 to indicate the two roots. And anytime I say R2, I smile because I really want to say D2. But here, R1 and R2 give me the roots. Those are the x-intercepts of the parabola. That's where they touches the x-axis. Another word for an x-intercept is a 0. That means the places where the value of that function is 0. Its output is 0. Its y value is 0. Okay? And then we have vertex form. Vertex form is like the holy grail of parabola forms because it gives us great information about where the vertex is. It tells us that the vertex is at hk. H on the x and k on the y is the location of the vertex. A would tell us the direction of opening, so we would know if H and K are a maximum or minimum. And we could answer those questions very easily. The trick is going from this form to this form requires some tricky algebra. Let's take a look. So we know that we have the standard form, ax plus by equals c. If I want to go from factored form to standard form, I have to expand and simplify. To go from vertex form, I expand and simplify. If I want to go from standard form to factored form, I factor. If I want to go from standard form to vertex form, I need to complete the square. This is the thing we are looking at today. To go from standard form to vertex form, complete the square. Okay? So here, let's remember, we have a point on the graph given by x and y. That's like, the ingredients of our function. The stretch factor of the parabola is there at A. And the value of the vertex here is the point h and k. Okay? So therefore, if I can get the parabola into this form, I know the maximum or the minimum value of the parabola. It's going to be the y value of the vertex. Because the vertex is either going to be the maximum if the parabola opens downwards, and so the y value would be the maximum value of the parabola. If the parabola is a bowl collecting rain, if A is positive and it opens upwards, then the vertex is the minimum, and that value of the vertex would also be given by k. So here we have some pictures that help us. Here is hk for this function, and it would be minus 5. So we would say the minimum value of this parabola is minus 5. Now that's useful information if you want to talk about the range of that parabola. Right. The range of that parabola would be negative 5 and greater than or equal to negative 5. In this case, this parabola, and we would see that more clearly if we had arrows on there, because this parabola does go off to infinity that way and that way. The maximum value of this parabola, which opens downwards, is 5. So y is a set of real numbers such that y is less than or equal to 5 for this parabola. Would be how I would talk about its range. All right, now let's take a look. We want to take a look at completing the square. And here I've put this on your handout. This gives you the steps to complete the square. You want to see examples. I want to show you examples. So we have a common purpose, everyone. Let's take a look at some examples. Now completing the square, here's a visual representation of what you're doing. Okay, you're saying I have an x squared term and then just like a bx term. So we have ax squared plus bx plus c. Here's my x squareds. Here's my b's times x's, my linear b times a linear x. And what I'm going to do is I'm going to cut that in half. I'm going to divide b into 2. And I'm going to create a square with a little gap in it. And then I'm going to add this little gap, which is b squared over 2. I'm going to add that to the parabola. In order to balance my equation, I'm also going to subtract it. So what I'm doing is a fancy add zero. I add something and then take it away right away. So I have not changed the value of the function. But what that allows me to do is create a perfect square. When I can create a perfect square, then I can turn it into factored form. And you'll start to see that starting to happen. We'll do some step-by-step investigations of this. And the section in your textbook is beautiful for this. So we're going to go over this tomorrow when I'm back. But for now, let's take a look. If we want to determine the value of m such that the quadratic is a perfect square trinomial. Okay, what does that mean, a perfect square trinomial? Let me do this one on the board, and we'll take a look at these examples. Well, the perfect square trinomial is something that can be written x plus a number all squared equals that trinomial. So, over here, just give them a chalk, and we'll do this one. So x squared plus 20x plus m. And we want m to make this a perfect square trinomial. Let's write it out. X squared plus 20x plus m. All right? It would be nice if this could factor down to x plus some number. I'll just call it lowercase a all squared. Okay, that's what I want. All right, it's just something like this because that's going to allow me to put it into vertex form. All right? Now, up here, what I'm going to do is I'm going to take half of this number and square it. So here I just notice my b, and I do a little bit of work on the side. My b is equal to 20. And so then I put b over 2 and square it, and that gives me 20 over 2. That's half of 20. And I square that is equal to 100. Okay? So I just do this little bit of work on the side. Yeah. All right? And that's an investigation that I'm doing to determine a value I can put here to create a perfect square trinomial. All right? Now let's take a look. X squared plus 20x plus 100. Okay, so let m equal 100 is what I do there. All right? X squared plus 20x plus 100. Well, that equals x plus 10 all squared. Let's expand and see if we got it right. This is equal to x plus 10 multiplied by x plus 10. Okay? Let's multiply it out. So we use FOIL. X times x is x squared. X times 10 is 10x. 10 times x is 10x. 10 times 10 is 100. Okay? Add those together, recreates this 20x. All right? So when we let m equal 100, we created a perfect square, something we could write this way. All right? And the way we found m was we took half of this and squared it.
Half of the 20x?
Half of the 20. Half of the coefficient of x, not half of 20x, because that would be 10x. And then when we squared that, it'd be 100x squared. We don't want to include the x there, just the coefficient. Okay? So this is the trick that you use to create a perfect square trinomial. You take half of this, square it, and then add that to your function. Of course, you're going to have to subtract that from the function again to make sure that you're not changing the function. Now, why does that work? Notice that I add those two things together. So that's why I had to divide it in half. And then I needed to square it because they end up multiplying each other here. So that's why this trick will work every time. All right. Take a look at one more example. People need a picture? Because I'm going to erase it. Go for it. Okay. One more example. X squared minus 4x plus m. X squared minus 4x plus m. So let's do a little investigation here. B is equal to negative 4. My B value here, this is a quadratic in standard form, ax squared plus bx plus c. I need to find a c that makes this work. B over 2 squared, well, that would be negative 4 over 2 squared is equal to 4. Negative 4 over 2 is negative 2. Negative 2 squared is positive 4. 4. Okay, so I'm going to let m equal 4. X squared minus 4x plus 4 equals x minus 2 squared. I don't want to check it. I just know it's right, okay? So you can check it on your own. Let's move on. Such a rush today. Oh, my goodness. Okay, this is the trick. You use that to find the value you're going to add and then subtract again from the quadratic. Okay, so let's carry on. So now, let's determine the maximum or the minimum value of this parabola. I have this example for you on your sheet, so I'm going to switch to the document camera, and you can follow along with me. Here we're given whole numbers. Keep it as whole numbers or fractions, all right? So let's go over to document camera, and here we go. We're going to rock our way through this one. So, am I going to find a maximum or a minimum value for this parabola? It's going to be a minimum because a is positive. So this parabola is shaped like that. The vertex is therefore going to be a minimum value. So I'm looking for a minimum value in this case. All right. First thing I'm going to do is rewrite this. Y is equal to x squared plus 12x minus 10. All right. Now I look at this and I say, okay, 12, I'm going to take half of that and then square it. So what is that?
Don't we have m?
It's already given here as negative 10. That's our c. But I'm going to add something and subtract it from the quadratic. And you'll see what I do here. Okay. So this is the same thing as saying y is equal to x squared plus 12x. And then I do a little bit of work over here. 12 over 2 squared is equal to 6 squared is equal to 36. I would really love it if I had a plus 36 here, but I better balance it. I better put in a negative 36, and then I have my 10, okay? See what I did? I added it, and then I taketh away. It's like the Lord giveth, and the Lord taketh away, okay? And that's how everything is fair, okay? The equal sign is still true. I've added 0. I added 36, I took 36 away, okay? So that's why I'm allowed to do that. Now I notice that if I put brackets around this part, that's now a perfect square trinomial. Okay, that's equal to y is equal to x plus 6 all squared minus 36 minus 10. Well, that's just minus 46. So, what's the minimum value of this parabola? What's the smallest value that this parabola could be? Negative 46. There you go. So I can read from this that this parabola is going to be on the xy plane. It's going to have an x value of negative 6 and a y value of negative 46. Okay, so this is a picture of this parabola. It's way down here. Why negative 6? Because it's x plus 6. And in my in my vertex form, x minus h plus k, hk gives me the vertex. I have to flip that sign. Okay. But I was asked to find the minimum value, so I would say, therefore, the minimum value is negative 46. Okay. Notice, I added something, I took that thing away. That means it's still 0. I'm allowed to do that, and that creates a perfect square trinomial. Where did I get this number? I get it over here, actually. Okay, so that's half of b. That's just my half of b there. It goes in there. All right, another example. Let's go. So determine the maximum or minimum value of y is equal to negative 2x plus 16x minus 23. This one I need to do one extra step. I'll show you the extra step. I know we're just at break. Let me finish this example, and then this example, I'll make a YouTube video. It'll be up by the end of the day. I have to get going. So here we go. First thing is rewrite. Y is equal to negative 2x squared plus 16x minus 23. All right, my first step, and if you go over here, it gives you the step-by-step things to do. The first thing I want to do is bracket the x terms and factor out the a. We didn't have to do that last time because we didn't have an a. We had an a of 1. So now I just go ahead and factor that out. Y is equal to negative 2 multiplied by x squared minus 8x minus 23. Just rewrite this with the a factored out. See what I did there? Yeah. Okay. So now I take half of that and square it. Negative 8 over 2 squared is equal to, well, that's negative 4 squared, which is 16. Okay. So I want to add 16 in there. So I'm going to have y is equal to negative 2 times x squared minus 8x plus 16, end bracket. What I have done here when I added 16 to the equation, I don't take away 16. I have to multiply that 16 by negative 2. Take a look at that. I actually subtracted 32 from the equation. Do people see that I just subtracted 32 from the equation? This is 16, I just added it, but I have to multiply it by this negative 2. People see it now. I didn't add 16, I subtracted 32. So to balance that, I need to add 32. Does that make sense? Yes. Good. That is going to be a very confusing point. If you can understand why that's 32 and not minus 16, it's because I have to multiply that one by the negative 2, and then I can balance. Okay? So now this is balanced. Now let's take a look at what it is. Y is equal to negative 2. This is a perfect square, and it's x minus 4 squared. Plus 32 minus 23, well, that's just plus 9. Now, when you get done something like that, you want to say, is this a maximum or minimum value? This is a maximum because this parabola is shaped this way. So the vertex will be a maximum, and that's the point HK. And the maximum is given by K, so the maximum of this parabola is, what's the maximum value of this parabola? 9. Very good. Yeah, so therefore the max is 9. Put a square around it, final answer. Okay, now after something like that, let's check our work in Desmos. We always want to do that, even if we're in a big rush. We still do that. And so here we go. I'm going to graph the one in Desmos, the first one, and the second one. Make sure that they're the same parabola. So I had y was equal to negative 2x squared plus 16x minus 23. And then I turned that into vertex form, and it became y is equal to negative 2 x minus 4 squared plus 9. Boom. They're congruent. They're the same. So there you go, completing the square. All right, thank you for showing up for your accelerated learning today, everyone. I wish you all the best.